The following presentation is for Nexio's BAT EMC software. In this presentation, we're going to show the manual modes for the new emissions interface we call Visu 4. Here we have a test that was previously run, and you can see we have data for the suspects above, and we have data for the finals below. Note that all of this testing was done using the automatic execution, whereby it did a pre-scan. It found the suspects according to the criteria set in the advanced suspects procedure. Then it did the final measurements, and that's what you see here, all done automatic. So let's say we're going to do measurement on just a single peak, and I want to remeasure or troubleshoot an item. For example, I can choose this peak up here that was found in suspects. So if I were to go to this first peak and say use for manual point, then the manual point will open, and you can see I have these different menu options. So I will choose the CISPR recommended settings because this is a CISPR test. I will initialize the setup. The block diagram appears just to verify the right resources are chosen. Then I can go to the max position that was found at the original scan. So I will say go to the max position. I can enlarge this window a little bit so we can see the positioners better. And the original angle was 149 with the height at 1 meter, so it should go back there. Now that we're at that location, let's do a continuous measurement using the peak detector with max hold. So here are the two major choices, maximization and final measurement. We're at the maximization stage. We will select free run, and the receiver will initialize. The bar graph will appear for the peak detector. And as you can see, we're doing continuous measurements in max hold. Okay, now this is the current azimuth max and height max. What we're going to do here is to manually turn the turntable and adjust the antenna mast to see if we can determine a new maximum. So what I can do is either manually set a target, such as 0, and then go. So it will go to 0. Besides typing in a target, it's also possible to simply hit the plus and minus buttons, or to press go to max. And any time I could have stopped it if I wanted to, but we're going to do the full 360 to see if we can come up with a new max angle. There we go. So the max angle is now 330 degrees. What I will now command it to do is to go there. Now we're at 330, and I can exercise the antenna mast to see if I can come up with a new value for the max height. I can put in a target or just simply go to max. Okay, so now that we've achieved the maximum height, I can now put in the target to go there, and that's going to be, we found it at 1 meter, so I'll just now say to go to min because I know that's 1 meter. Okay, now we return to the 1 meter location. So currently we are at 330 degrees on the azimuth and 1 meter on the height. So indeed we're at the max position. I can stop that measurement. And now we're going to do a final measurement. Because we're in a range below 1 gigahertz, we're going to use the quasi-peak detector for that. And as you can see, because I changed to the quasi-peak detector, the measurement time came up to 1 second. It could be set to a higher amount, for example, if the peak was unsteady. And then I can say to do a single run, because that will measure it. It will do a continuous measurement in max hold, and will record that value as the final value after the measurement time expires. The previous measurement in free run would not stop until commanded to do so. Now I can select single. It'll do a single measurement. And here you can see the new results. So we have the new values, we have the new delta, and we can store this to the table of finals by selecting store. And if there was a previous peak that was measured at that frequency, if I don't want to override it, I make sure that I do not select that box. So now that when I store the result, you can see I have the new result here, and that's the one that was done manually. Another thing I'd like to show you briefly is the fact that I could have also clicked on a particular peak that wasn't found prior, and then use that peak for a manual point measurement. For example, I have that cursor on that peak. You can see cursor 1 with the peak information here. I can then use this button to transfer to the manual point, and there you go. You can see that we now have a new frequency. I could go to the new max position for that, and it will drive the positioners to the location where that was found, and I can begin the process all over again. I'm going to stop this initialization. Now let's explore another manual mode. I've switched to a conducted test. The two reasons are it is faster, and it also doesn't involve a positioning system, so it will be simpler for the demonstration purposes. Here you can see I have the tabular data above. The previous suspects were found according to the criteria, and when you had the table of finals below, these were measured against the suspects. So let's say I want to remeasure a particular area. I can go to manual operation mode, and then the dialog box states to select the frequency range on the chart using the shift click or select all. So I'm just going to do the shift click, and we can remeasure this area here, for example. And I can now state to do a pre-scan. So I have different options, advanced or simple, etc. I'm going to do the regular, use the peak detector, and now it's going to remeasure that area. The block diagram appears, and we verify the setup. Phase 1 first. And then after line 1 we have neutral. And there we go. I have data that was ran for this area. Let's say I want to run the suspects on that. Then it's also possible using the data reduction. Recalc advanced suspects. So let's see what we get here. I am going to compare to the average limit line, which is correct. Looking for a 6 dB offset. Okay, that's correct. Maybe I want to increase that offset. How about if I increase it to -10 for this purpose? Okay. So I'll run the advanced suspects. And you can see we had a new suspect highlighted, and that is approximately in the, if I click on that, approximately in the 370 range. So if I were to come up here, select that peak, then I could execute the final on it. And I'm going to do advanced. That way I make sure that I'm using both detectors, and then I can store the results the way I would like them. I'm going to change the measurement time in this case just to 1 second. We'll consider that it is a steady disturbance. And then OK. First phase 1. And here we go. We now have a final measurement for that peak that we found using the remeasurement mode. Okay. Let's go to that peak, and let's say I want to add a comment. So it says double click to edit the comment. I will double click and I can add a comment for this. Peaked, measured manually, and I can say added ferrite, for example, ferrite model, 1, 2, 3, something like that. And there you go. Now I have a comment associated with that new peak that I remeasured. And this is very useful. It's a similar process that can be done for the manual point mode as well as the manual operation mode using a range to track the new tests that were done and any notes, for example, turning data on and off, adding ferrites, changing cables to shielded cables, and so on. This can be extremely useful in the investigation modes, and it can also help you track the changes. So within a test, it's easy to compare from one remeasurement to another. It's also possible to use the list of external curves, and with the list of external curves, it would be possible to import curve from a previous test. I have some in this previous project that was run, so I could import a previous curve to compare, as well as from a file. So more options here as far as how to do investigation modes, how to compare one remeasurement to the next, and then also how to compare from previous tests, previous curves or curves imported from, let's say, files or external test labs. Lots of options here. This concludes the demonstration for the manual measurement modes for the new emissions interface for BAT EMC version 3.20.